All right, guys, so let's get into the meat of this lesson today. So we're going to go over graphing standard form. So if I'm looking at a quadratic function in standard form, the general equation is y equals ax squared plus bx plus c. So this is a form in which a polynomial is written. Terms are placed in order, if we look at this, from the highest exponent to the lowest exponent. So in this case, if I'm looking at this, our highest exponent is x squared, so to the second power. Then b of x, that's going to be x to the first power, and our c is technically x to the 0 power. So it is a constant. There is no x value there. There's no x variable in that term. So letters a and b, notice that those are in front of our variables, so they are coefficients. And letter c is a constant. And then we have this statement that says the blank of the quadratic function is a c value, and it gives us 0, c. Remember, if your x value is 0, that's going to mean that the y-intercept of the quadratic function is a c value. So that's where our quadratic function is going to intercept the y-axis. So let's look at these examples 1, 2, 3, and 4. And it says to look at the quadratic function in equation form and identify the a, b's, and c's. So example 1 says y equals 3x squared plus 4x minus 5. Let's look at our a value first. This is going to be the coefficient on our highest order term. So in this case, our a value is 3. If I'm looking for my b value, this is going to be the coefficient on my x term. So in this case, it's 4x, so my b value is 4. And then my coefficient is my c value, which in this case, got to take our sign with us, so it's -5. So make sure you're looking at your signs. Example 2 is y equals x squared plus 2x plus 10. Well, Miss Adams, we've got an x squared, so does that make a x squared? Absolutely not. Remember, we've got to put a understood coefficient of 1 anytime that there is not a stated coefficient. So our a value in this case is 1. Our b value is 2. And our c value is 10. Let's go to example 3. So if I'm looking at example 3, it tells us that y equals -2x squared plus 4. Miss Adams, this only has 2 terms. It's not a quadratic function. Actually, it is a quadratic function because it has a order of 2. So that x squared, or excuse me, that degree of 2. So it's -2x squared plus 4. So even though an x term is not stated, it's still understood to be a quadratic function. So our a value is -2. But because we don't have this x term, it's understood to have in between here a 0x. So our b value is 0. And our c values are constant at the end there, which is +4. Likewise, if I look at example 4, I have y equals 5x squared plus 2x, but I'm missing a constant at the end. So it's understood that this is adding a 0 at the end. So our a value is 5, our b value is 2, and our c value is 0. Now it says to complete the table of values and sketch a graph of y equals x squared minus 4x plus 5. So guys, make sure you grab a calculator at this point, and we're going to go into the table function of the calculator and enter in x squared minus 4x plus 5. And we will fill in those values from the table. So if I look at where x is 0, my table function gives me a y value at 5. Where x is 1, I have a y value at 2. Where x is 2, I have a y value at 1. Where x is 3, I have a y value at 2. Where x is 4, I have a y value at 5. So let's graph that function. So where x is 0, I have y of 5. Where x is 1, I have y of 2. Where x is 2, I have a y of 1. Where x is 3, I have y at 2. And where x is 4, I'm back up to a y at 5. And that gives us our parabola. And if I look at that parabola, so let's just take a moment and examine it. First off, it doesn't seem to have any x-intercepts because it does not cross the x-axis. It has one y-intercept. And this is a parabola that's facing upwards. So I know that the end behavior in both cases is whenever x is going to negative infinity, y is approaching infinity. Or when x is approaching positive infinity, y is also approaching positive infinity. So let's look at our y-intercept. This is where x equals 0. So in this case, our y-intercept is at 0, 5. Now, before we look at the axis of symmetry, I'm going to look at the vertex. So our vertex is, in this case, because it is an open-facing parabola, is going to be our minimum value. So it's going to be down here at our lowest value. You can actually look at your table to figure out where your y value is the lowest. So our vertex is at 2, 1, making our axis of symmetry then. Going through that x value at 2, so x equals 2. And direction open, we had identified that first, so it's opening up. And we do not have any x-intercepts. So I'm just going to put none for my x-intercepts. All right, let's look at example 2. It says determine the following information and then sketch a graph of y equals negative 2x squared minus 8x minus 2. So we're going to go back to that table function in our calculators, and we're going to put in negative 2x squared minus 8x minus 2. And let's just start at, let's change it up a little bit. Let's start where x equals negative 2. So where x equals negative 2, my y value is 6. Where x equals negative 1, my y value is 4. Where x equals 0, my y value is negative 2. And then where x equals 1, my y value is negative 12. Where x value is 2, my y value is negative 26. Now this kind of goes off our graph. So if you're looking at this and you're like, hey, this is not really helping me out too much, go through that table function and find where you have a turning point. So where your y values start repeating again. So if I would have gone back a little bit further, so let's go ahead and erase this. Let's go back a little bit further. Let's try starting off where x equals negative 5. Well, when x equals negative 5, our y value is negative 12. Where x equals negative 4, my y value is negative 2. Where x equals negative 3, my y value is 4. Where x equals negative 2, my y value is 6. And where x equals negative 1, my y value is 4 again. You could continue on and say, just to follow the pattern, where x is 0, y is negative 2, so on and so forth. So let's go ahead and graph these points. So at negative 5, it goes, my y value is all the way off the graph at negative 12, somewhere around there. When my x value is negative 4, my y value is negative 2. When x is negative 3, my y value is at positive 4. So make sure that when you're graphing these, you're graphing them as accurately as possible. So I'm at negative 4, 2, negative 3, 1, 2, 3, positive 4. Then we're at negative 2, 6. And then it's going to start turning back around on us. At negative 1, it's going to go to 4. At 0, we're going to be at negative 2. And if we were to continue to go on, at 1, we'd be at negative 12, which then again goes off the graph. So let's clean that up just a little bit here. So we're at negative 2. and then it would go off the graph at 1. So here's our parabola. All right. So just looking at this, let's look at our end behavior. As x approaches negative infinity, our y value also approaches negative infinity. And then where x approaches positive infinity, our y value is again approaching negative infinity. This parabola looks like it's been turned upside down. So it kind of is like a bowl that has been flipped over. So in this case, our end behavior, our direction is pointing downwards. So let's look at our y-intercept. So that's where x equals 0. Our y-intercept then is at -2. Then if I look at my axis of symmetry, I'm going to look where my vertex is, or that turning point. My vertex is up here at -2, 6. So that means my axis of symmetry is where x equals -2. Now this one's asking for our domain and our range. Remember, the domain for all the functions that we're going to be talking about in Algebra 1 is going to be negative infinity to positive infinity, or you can say all real numbers. And then our range is going to be also dealing with our vertex. So in this case, I know, looking at the bottom, our range is going to go down to negative infinity. But then it's going to go all the way up to where my vertex is at 6. So it's going to include that value of 6. And that's the highest point. So you could write that as y is greater than, or excuse me, less than or equal to 6. Both ways work for the range.